hydrologic cycle, also known as the water cycle, is a conceptual model that describes the storage and movement of water between the biosphere, the atmosphere, the lithosphere, and the hydrosphere. Besides the ocean and water itself, the sun is one of the most important pieces of the hydrologic cycle. See, the sun's energy, the light and heat and radiation, all make a crucial part of the water cycle possible. Evaporation. Evaporation is the change of state in a substance, in this case water, from a liquid to a gas. This change doesn't just happen though. Energy from the sun is used to break up the bonds that hold the water molecules together, allowing it to become water vapor. Evaporation from the oceans is the primary mechanism supporting the surface to atmosphere portion of the water cycle. It is estimated that the oceans supply about 90% of all of the evaporated water that goes into the water cycle. After all, the Earth's ocean, all 139 million miles of it, contains about 317 million cubic miles of salt water, providing a massive area from which evaporation can occur. Now, evaporation from the Earth's open water isn't the only contributor to water vapor. Evapotranspiration is also responsible. Evapotranspiration, broken down evapo and transpiration, is the water lost to the atmosphere from the ground surface. The transpiration is essentially evaporation from plant leaves. Actually, about 10% of the moisture found in the atmosphere is released by plants through transpiration. Regardless of how water is evaporated, once it is, a water vapor molecule only spends about 10 days in the air. As vapor rises higher and higher into the air, it gradually cools off. Eventually, this cooling process causes the water vapor to turn back into a liquid. This is how clouds are created. See, clouds form as water vapor cools and condenses into droplets and ice crystals. This whole process is called what else? Condensation. Condensation is essentially the opposite of evaporation. Since water vapor has a higher energy level than that of liquid water, when condensation occurs, the excess energy in the form of heat energy is released. So, instead of liquid water gaining energy to become a vapor, water vapor loses energy and becomes tiny little droplets of liquid. Water droplets in clouds bump into each other and get bigger and bigger and heavier. Eventually, when a cloud particles grow large and heavy enough, they fall as rain or snow or sleet or hail, and that is called precipitation. It takes millions of condensed cloud droplets to produce even a single raindrop. Did you know that precipitation is the primary way we receive fresh water? Yep, on average, the world receives about 38.5 inches of precipitation, mostly in the form of rain, each year over both oceans and land masses. Now, once precipitation has fallen over the Earth's land surfaces, the water can follow many different paths. Some evaporates, returning back to the atmosphere, and some seeps into the ground soil or porous rock as soil moisture or groundwater in a process called infiltration. And some water, in the form of surface runoff, travels over the soil surface and into rivers, streams, or other kinds of channels. But almost all of the precipitated water eventually flows into oceans or other large bodies of water, where the cycle continues. These different types of water storage tie into the crucial concept of global water distribution. One part of the water cycle that is obviously essential to all life on Earth is the fresh water existing on the land surface. Surface water includes the streams of all sizes, large rivers to small creeks, ponds, lakes, reservoirs, even freshwater wetlands. Take a look at this chart. Notice how, of the world's total water supply of about 332.5 million cubic miles of water, over 97% is saline, and of the total fresh water, over 68% is locked up in ice and glaciers. Another 30% of fresh water is in the ground. Fresh surface water sources, such as rivers and lakes, only constitute about 22,300 cubic miles, which is about 1/150% of total water. Yet, rivers and lakes are the sources of most of the water people use every day. The Pacific Ocean is the world's largest ocean. Incredibly, it accounts for more than half of Earth's entire ocean space. Not only is the Pacific Ocean also the deepest ocean, but it's Earth's largest geographical feature. The Atlantic Ocean, however, is only half the size of the Pacific Ocean. It's also a lot more shallow than the Pacific Ocean. The Indian Ocean is smaller than the Atlantic and similar in depth, but is primarily in the southern hemisphere. The Arctic Ocean, while only about 7% the size of the Pacific, is the shallowest ocean, but it has a permanent layer of sea ice a few meters thick covering it. While the Antarctic Ocean circumnavigates Antarctica, it's really parts of the Pacific, Atlantic, and Indian Oceans that lie south of the 50-degree south latitude. The differences in these oceans bring to light the differences in sea life that might inhabit them. For instance, in shallow waters, there's a lot of familiar marine life, like crabs, lobsters, shrimp, clams, eels. However, the oceans are divided into different zones. The sunlight zone and the twilight zone are the only levels of the ocean that receive sunlight, so creatures that require photosynthesis cannot live any deeper than the twilight zone. While this chart explores sea life in more depth, the midnight abyssal and trench level receive no sunlight. However, life exists at the deepest levels. Most of these are invertebrates such as basket stars and tiny squids. 3/4 of the ocean floor actually lies within this zone. Every living thing, all living things on our planet need water to live and survive. That's why this whole thing is so important, the water cycle. Almost all of the water in the world is the same water that has been here since the Earth formed. There are many commonly held student misconceptions concerning the water cycle. For instance, that the water cycle only includes the process of evaporation and condensation. That is, however, false. The water cycle includes all of the topics we have discussed in this video. The energy from the sun, evaporation, evapotranspiration, condensation, precipitation, runoff, infiltration, groundwater, fresh water, ocean water, everything. Another common misconception is that cold water can't evaporate. That's obviously false. The key to understanding evaporation is in the movement of the water molecules. Water evaporates when fast-moving water molecules escape the liquid. Because water molecules are always moving and bumping into each other, the speed of individual water molecules is constantly changing. After molecules bump into each other, one may bump away with greater speed, and then the other with less. In hot water, many molecules are moving fast enough to escape, and water quickly evaporates. However, even in cold water, some of the water molecules are moving fast enough and have enough energy to escape from the liquid and go into the air. Yet another misconception is that water only evaporates from the seas and oceans. Water evaporates from everywhere, anywhere. All water, even water in plants. Transpiration. Another common misconception is that rain falls when clouds evaporate, when in fact rain falls once evaporated water particles have risen and condensed into clouds, then grown larger and heavier to form precipitation.
Yeah. I represent the movement of water, that's my purpose. Whether on, above or below the earth's surface. In the continuous cycle, my work's never done, cause I'm driven by energy from the sun. I travel through the sea, through the air, through the ground. You could say that water really gets around, but in fact most water's just chilling in the oceans. Only a small fraction is really in motion at any given time, but yo, that's the way it goes. When we're studying the voyages of H2O, in the cycle water changes states at various places, of 3 states being ice, liquid, and water vapor. But this cycle strays from the norm, cause through the process water still keeps the same structural form. While other cycles involve chemical change, water may change states but its structure stays the same. I rise to the sky from the sea below, then down to the ground as rain and snow. I keep it moving, moving, cause I'm the water cycle. Moving, moving, cause I'm the water cycle. Rise to the sky from the sea below, then down to the ground as rain and snow. I keep it moving, moving, cause I'm the water cycle. Moving, moving, cause I'm the water cycle. So when water transforms from liquid to gas and rises up into the atmosphere, that's evaporation, a process made possible by energy from the sun, also known as solar radiation. And when this water vapor in the sky reforms into liquid water droplets, that's condensation. And when this water falls back down to the earth as rain, snow, hail, or sleet, that's precipitation. Plants have their own type of evaporation through their stomata, which is called transpiration. So collectively the term used for transpiration plus all other evaporation is evapotranspiration. Two more terms to add to your collection. The movement of water through the air is advection. And speaking of keeping it moving, understand that runoff is water flowing across the land. I rise to the sky from the sea below, then down to the ground is rain and snow. I keep it moving, moving, cause I'm the water cycle. Moving, moving, cause I'm the water cycle. Rise to the sky from the sea below, then down to the ground as rain and snow. I keep it moving, moving, cause I'm the water cycle. Moving, moving,